Hi, my name is Tal. This is a video briefly demonstrating how I install the dependencies for facial recognition software. Um, I would like to start by saying that if you understand Docker better than I do, and you have any tips or corrections, I would really appreciate it. I'm here to learn. And second, I want to talk a little bit about why I did this in the first place. So, uh, face recognition, the library that I used for the face recognition project, it required dlib. Dlib is a very significant player in Python libraries regarding AI, and this is to be expected in a lot of AI platforms, AI libraries in Python. And dlib, it requires C, C++, and CMake, and this is quite the challenge because this does not come installed by default with Amazon Cloud Shell. So we have to install it ourselves, and the best way to do that is to use a Docker container because we get to simulate the operating system that AWS Lambda uses, meaning we get to compile the binaries such that they are compatible with AWS. And so that is what I did here. I installed these dependencies such that they were compatible with AWS Lambda. These are the two tools that you're going to need in order to perform this operation. First is some kind of shell. I'm using Windows PowerShell. And the second is Docker Desktop. I won't demonstrate how to install it. There are much better people at doing that, especially at defining containers and images. So I will simply show how to perform this operation. So the first, you're going to look for the correct image. This is going to be Amazon AWS Lambda Python, and you'd like to use the verified publisher. And we won't want to press pull or run just yet. We want to make sure that we're using the right version of it. So we want to use the latest version of Python, 3.14, and the latest version of which. And we are going to paste this. We don't need to paste the Docker pull part, because that we're going to do later. And we're going to type our command. Once you have your image copied, the link to your image copied, we're going to want to run the command that starts our Docker container. So first, find the folder that you'd like to perform the operation in. I'm just using a temporary folder in my documents folder because I intend on deleting this as soon as this video is over. And we're going to run our command. So we're going to start with docker run. This is just the prefix for every Docker container. Next, we want to do --rm. This means once I'm done using my container, delete it. I don't want it lingering. Next, I'm going to do -it and --entry point bash. These two parameters mean basically the same thing. -it means once this container is open, I would like to open a shell that I can write in. And --entry point bash also means once this container is open, I would like a shell that I can write in. But -it is general for all Docker containers. And --entry point bash is the first command that we're running once this container opens. And that command is I would like to have a Cloud Shell terminal that I can write in. So it's specific to Amazon Cloud Shell. But they perform the same operation. The next parameter that we'd like is -v w/. So these are a few things. First, we start with -v. -v means I would like to mount a volume, and a volume is persistent data storage in Docker. Persistent data storage meaning that it does not get deleted once our container gets deleted with --rm. The next is where I would like to save the files that I install with the container. There are different places to put this, and different places have different implications. If I were to do something else, if I were to mount this volume into the Docker Cloud, I could automate this whole process. I did not like that for me. I wanted to install it directly into a folder so that I had more control over the operation. And I also wanted to write everything myself. I didn't want to automate it as an amateur. So this was how I performed the operation. And so the location that I'm installing these dependencies, pwd means wherever I am right now, and /work meaning I would like to be where I am and also create a folder called /work. -w means then navigate to the folder /work. This /work is just a common practice with Docker. It is not something that I created, it's something that I'm copying. So this is general practice and I encourage doing the same. The last parameter is going to be the image that we copied. And once we have this, we can press run, or we can press enter. It's going to start saying we can't find it, so it's going to install it itself. Once you have the image up and running, it becomes a container, and the first command that we're going to run inside of our container is not necessary, but in my research is the best practice. So we're going to run dnf upgrade and run that. And it's going to get us the most recent version of our installation command. As you can see, it says nothing to do. And again, my research has said that this is good practice, and I have had many attempts at this, more than I probably should have, so I have had to upgrade in the past, but this version has it already installed. Alright, so now that we have DNF fully upgraded, we're going to want to install all of our dependencies. So there are two categories of dependencies. The first is Python. We'd like Python, pip, we want the ability to create a .vem environment, but these are all handled as we're using the Amazon Python version of AWS Lambda. We could have not used that, but this is the best way to do it in my opinion, and so we no longer need to install the Python. But we do need to install CMake and C++. So we're going to write dnf install. We're going to do -y so it doesn't pester us with questions. And we're going to write CMake, write gcc, write gcc-c++. And these are our dependencies. So once our dependencies are installed, we're going to want to start our Python virtual environment. And the reason we want to do this is that it gives us more control over where our dependencies are installed and which Python and pip versions we're using. So we're going to write Python 3, Python 3 -n then dot. I'm sure this is fairly familiar. Once you create your virtual environment, you can finally install face recognition in the library. So first we're going to navigate to our local pip. This is the one that we've created for our virtual environment. I'm going to type install face recognition. Eventually, you will install some things. It's going to go well. It won't be too much. And then you're going to get to building wheel for dlib. This takes so long that you're going to think that nothing is happening, but it's just taking that long. Usually it takes me about 10 minutes. This is a really long installation. So if it's taking too long, it is working. It just takes that long. Alright, once you've waited 5 to 7 lifetimes for dlib to finish it, for Python to finish creating the wheel for dlib, you'll be able to continue with the operation. So we've essentially finished the functions that our shell and Docker are supposed to perform, and the next thing we're going to do is going to find our little freshly baked cookies in our folder. So I will navigate to temp. It will be in lib, and site packages, And this wonderful folder right here is what we're going to look for. So that's in your folder. This is the folder. We're going to find lib, Python, and it's going to be under site packages. Alright, so now we've downloaded our dependencies such that they are compatible with AWS Lambda. We're going to upload them to our Lambda function. So this requires a few steps. The first step is going to be to first know what that means to upload a dependency. So we're going to go to our Lambda function and we're going to scroll all the way down to layers. Layers are where we put in our Lambda dependencies. So there are different ways to actually, first I want to say that when you're uploading your dependencies to a layer, it has to follow a very specific folder structure because it's what our function is going to look for. And in our case, it's going to look like such. So we're going to start off at layers. We're going to press info, and we're going to press on this link, but I'll show you a more general way of getting to that. So we're going to look up Amazon Docs, and we're going to look up AWS Lambda. We're going to go to the developer guide. We're going to scroll all the way down to Lambda layers, and we'll see managing dependencies with layers. And we're going to go into packaging layers. This is how we're going to make sure that our file structure matches what Lambda is looking for. So the gist of it is that we have our dependency as a zip file. You can call it whatever you want. And then it's going to have each language, its structure, and all of your dependencies. So you can see what they are for Node.js, see what they are for Python, for Java, and such. We're going to be doing this for Python. So we're going to follow just a folder called Python. So in practice, we're going to start with our folder where we put all our dependencies, and we're going to go into lib, our version, and site packages. As you can see, we have NumPy, we have Python image library, pillow, dlib, we have everything that we need. And this folder right here, therefore, should be called Python. So what we're actually going to do is we're going to copy this, and we're just going to paste it somewhere a little bit easier to manage, because we are going to be renaming this folder. Make sure that we have everything, looks similar enough. We're going to rename this, or not copy, we're going to rename this. We're going to call it Python. And this is what we're going to upload. So we'll compress this. Once we have successfully compressed our dependencies, we can name this folder whatever we want, but I'm going to call it Dependencies. Alright, our next goal, now that we have installed and compressed our dependencies, we want to add it as a layer. But the first thing that we have to do before that is we have to create the layer. And before we do that, we have to upload our dependency file into an S3 bucket. And the reason we have to do this is that we cannot directly add our dependencies folder because it's too big. The file is simply too large. So we have to use a middleman, and that's going to be an S3 bucket. So I'm not going to create a bucket for this. I'll just upload it into my folders bucket. We're going to add files, and this is where I put our dependencies folder, and I will press upload. Now once it's done uploading, we're going to access our zip folder, and we're going to copy its object URL. Next, We're going to proceed to our management console. I'm going to go to Lambda. I'm going to go into layers. We're going to create a layer. We're going to call this just dependencies, so this is easier to find. We're going to upload a file from Amazon S3. We're going to paste our folder. For compatible architectures, I installed Docker with x86, and also my Lambda function runs in this. And compatible runtimes, this is in Python 3.14. We're going to press create. Once it's going to be created, we're going to be met with this page. We're going to copy its Amazon resource name. It's ARN. We're going to go to Lambda. We're going to find our function. We're going to go to add a layer under layers. We're going to specify an ARN, paste it, and press add. And there we go. We have officially added our layers into face recognition. So thank you so much for watching. This has been awesome.